Here we are, on to the next chapter, and this is really exciting because this is pretty close to a solution that's going to show results very quickly. And the governments also should support it because the payoff in terms of co-benefits are going to be tremendous and obvious very quickly as well. And many of the technologies exist, many of the agreements exist, all the bad things about them are known. So this is about technologies for super pollutant mitigation. And we talked about it before in terms of the clusters and solutions we had looked at early on in the course. We had 10 scalable solutions, science solutions, societal transformation. I'm not going to read all of them here. Governance solutions, so ranged from basically bending the warming curve immediately by reducing SLCPs or short-lived, short-lived, I think is the way they say it, climate pollutants, and long-term by replacing current fossil fuel energy systems with carbon-neutral technologies. Under the governance solutions, we had the idea of building upon and strengthening the Paris Agreement, strengthening sister agreements like Montreal Protocol and the Kigali Amendment to reduce the HFCs, hydrochlorofluorocarbons, that are used as refrigerants, and while they don't affect the ozone hole, they are really bad for global warming, with a huge global warming potential compared to CO2, for example. Okay, so market-based solutions, technology-based solutions, and solution number 9 here was immediately make maximum use of available technologies combined with regulations to reduce methane emission by 50%, reduce black carbon emissions by 90%, and eliminate high global warming potential HFCs ahead of the schedule in the Kigali Agreement while fostering energy efficiency. So that's the key. In the book it's written as 50, 80, 100, but here is 50, 90, 100. So 50% black carbon reduction, 90%, sorry, 50% methane emission reductions, 90% black carbon emission reductions, and 100% elimination of HFCs. Okay. To revisit several of the ideas we have already talked about, SLCP climate benefits in terms of avoided global warming can be looked at. Of course, SLCPs are black carbon plus methane. They are short-lived because the black carbon has literally a week. If you stopped black carbon emission, you would see the impact in a couple of weeks. How amazing is that? Methane, order 12 years. HFCs, depending on which variety, you get up to 20, 25 years, 15 to 25 years, and other short-lived climate pollutants. So this, by 2050, we can avoid warming of half a degree with black carbon and methane. HFCs would give us 0.1 degrees, and SLCPs would give us totally 0.6 degrees. So this is the sum here. So this is the projections from 1900, and we are here somewhere. The historic warming of over 1 degree centigrade by now, about 1.8 or so degree Fahrenheit. Business as usual, not doing anything about climate mitigation is going to take us up here into what is generally considered the danger zone. Dangerous anthropogenic interference, for example. CO2 only would still keep us in the red zone but bring us down below 3 degrees centigrade. Black carbon plus methane only would give us a little bit more reduction, especially early on. and because methane also eventually gets converted to CO2. Mitigation of CO2 plus SLCPs is going to bring us down here with full mitigation. Obviously, under 2 degrees is still very good, which is one of the goals. So what are the short-lived climate pollutants? We talked about black carbon with the various sources, anthropogenic sources with their lifetime in the atmosphere, the residence time, and the impacts. Black carbon mostly has local impacts with a few days of residence time. Methane has 12 years with local and global impacts because if it gets converted to CO2, then it becomes part of the CO2 greenhouse warming. Tropospheric ozone, which we don't emit directly, but we emit all the precursors as we will see. So whatever mitigation efforts we make for methane are also going to help bring down the tropospheric ozone, which is also very bad for health and for crop damage and so on, which we will see. Has residence time of weeks, heavy local impacts with some global impacts. HFC's 15 years weighted by usage, and it has a global impacts. Okay, so long-lived climate pollutants, long-term response to mitigation of CO2. We have various other measures which we will not look at here. But looking at the impacts of the short-lived climate pollutants, obviously bad for public health. Reduces food security because of impacts on crop yields, negative impacts on crop yields, which we will look at. Obviously warms the atmosphere, increased ice and snow melting with all its consequences on coupled climate feedbacks and impacts on socioeconomics, livelihoods, etc. And disrupt weather patterns. There is plenty of evidence that they impact extreme events, sea level rise, and so on, directly and indirectly. So mitigating SLCPs is going to have all those co-benefits: health, food security, sea level rise, and so on, that we will look at. Okay, very nice chapter with lots of very good practical, immediately implementable ideas that actually should be implemented to achieve the short-term bending of the curve, which is the goal.